This is Lesson 5, Unit 3 notes. You've already learned how to graph how to solve systems of equations using the graphing method and the substitution method. So I want to go back and just a reminder that let's solve this one using the graphing method. So right now it's not in a very good form. So I'm going to write it out and solve for y. And this is something you should already know how to do. Divide both sides by -2. So I get y equals negative divided by negative is positive. And this 1/2. So this one has a y-intercept of -1/2. And then you're going to go up 3/2. So 1, 2, 3 over 1, 2. So this graph is going to look something like this. If I solve this one for y, I would subtract 2x from both sides and then divide both sides by 2. So y equals -x plus 2. So I start at 2, and I'm going to go down 1 over 1, down 1 over 1, because it has a slope of -1. And you can see how this graph crosses at 1, 1. So because this has one point of intersection, this has one solution, and the solution is the point 1, 1. What makes it a solution is if I put 1 in for x and 1 in for y, this becomes a true statement. If I put 1 in for x and 1 in for y here, this is also a true statement. This is the only ordered pair that is on both of these lines. That's what makes it a solution. So in the previous lesson, we would have just solved these by substitution. I'm not going to do that this time. I would show you, but I would never solve this problem by substitution. Because whenever I solve by substitution, I really want one of these variables to only have the number 1 in front of it. And since there's a different number other than 1 in front of all the variables, I would never solve this one by substitution. So I'm not even going to show the example of it. But what I want us to do is go down here to the bottom of the notes and solve this same problem using the elimination method. So remember up the top that these lines crossed at 1, 1. So we said 1, 1 would be the only solution for this problem. So let me show you the elimination method. I know that I want to use elimination when I have variables that are lined up. So here x's are lined up, y's are lined up, equal signs lined up, and 1 and 4 are lined up. So this is really nice. The other thing I notice about this one is this equation has -2y, and this equation has +2y. That makes this problem ideal for elimination. Another name for elimination is linear combination. And when you combine things, you add. So what I want to do is combine these two equations by adding. So when I add vertically 3x plus 2x, I get 5x. When I add -2y plus +2y, that eliminates and becomes 0y. So I'm just going to draw a line through that looks like this. And then bring down my equal sign, and 1 plus 4 is 5. So now I have an equation that only involves the letter x. So now I'm going to divide both sides by 5. So I get x equals 1, which is exactly what I got for x when I graphed. Then I'm going to go back and I can either pick the top equation or the bottom equation. It doesn't matter which one. I usually try to pick the one that looks the easiest to me. And I'm going to put x in for, I'm going to put 1 in place of x. So I'm just going to pick the top equation, which is 3x minus 2y equals 1. And I'm going to put 1 where x is. So 3 times 1 minus 2y equals 1. So 3 minus 2y equals 1. subtract 3 from both sides. So I get negative 2y equals negative 2. Divide both sides by negative 2, and y equals 1, which is exactly what we got with substitution. But this time we use the elimination method, or the linear combination, which means you stack them and you add.